Good day, my name is Guy Mutsaerts. I'm working for Goudsmit Magnetic Systems in Waalre, the Netherlands. Today I want to tell you a little bit more about Gauss value. What is Gauss telling you about the efficiency of your system? This in addition to the previous video that we have made for force index. The Gauss value of a bar is depending on several parameters. It can be the thickness of the pole plate, it can be the thickness of the magnet, it has various parameters. To have a good test, we decided only to change the size of the pole plate. If we make the pole plate instead of 1.5 mm, 6.5 mm, the Gauss value will drop from 10,000 to 8,000 Gauss. We still use the same magnets. So we did a test with a rotor with those bars, and what we also did is that we changed also the position of the magnets in the rotors to see what will happen. The outcome of the test was very remarkable. We did a test with the 10,000 Gauss rotor and we found out that only 78% was captured. The test with the rotor of 8,000 Gauss, we found out that 19% was captured. The test was done with SUS parts because iron parts are easily caught, and with SUS we see a more better difference. Why did we do that test? Now, you see here the configuration of the bars. And you see also that the gap between the bars is maximum 35 millimeters. So one bar is going 70 millimeters to one side and the other bar is going 70 millimeters to the other side, so that you can close the gap. So what we did is that we made a graphic where you see the Gauss value of those two systems. And at a distance of 4 millimeter, the rotor with 6.5 millimeter pole plates is crossing the rotor with 10,000 Gauss of 1.5 millimeters. Let's go deeper in that. And then we see that it looks a little, but it's about 250 Gauss difference at 4 millimeters and wider from the bar. So this could be a conclusion that when you have higher Gauss values, the catch field, the catching is also better. So a deep catch field will also bring better separation. Then what we also did is we tested the position of the magnets. You have two possibilities, as you can see here in the slide. You have the possibility of same polarity and you have the opposite polarity. On the top you see same polarity, south-south and north-north in front of each other. There is no interaction between the magnets. If you have the other polarity, south-north, north-south, there's a lot of interaction between and you have a high flux density. We measure several things. It is of course clear that when the smaller the gap is, the more easier it will be to trap the iron. But in practical, this is very difficult because if you have a small gap, the product cannot pass. Another problem for us is that the influence of those bars with each other is so high that you cannot clean it anymore. It's very difficult to handle. So we have to find a way what's the best in practice and what's in theoretical best. Theoretical, it's the best to have a gap of about 80 millimeters only. Then you will catch about 90 to 100%. But as is not practical, we decided to keep the gap 35 millimeters. Conclusions for the best execution. Distance 80 millimeters, it's not possible because it's difficult to handle. Proven that 8,000 Gauss is a better separator than 10,000 Gauss, that's true, that's what we saw. As we have the low capacity, we have chosen to have a wider range instead of the 80 millimeters that was wanted. Out of this application test, we can say about Gauss and efficiency. If the Gauss value is below 300 Gauss, a good separation is not possible anymore. So we have to keep that in mind. There is a maximum distance between the bars. The pole configuration, north-north or north-south, is important. A configuration with an opposite pole is better than one with identical poles. A thin pole plate which will give high Gauss value will give less separation than a thicker pole plate with a lower Gauss value. The particle size must be bigger than 100 μ. More pole plates will give a better separation, but a lower magnetic field. Yes, of course, more pole plates, you have more contact points and more points where you can separate. There are many things that influence our separation degree. We work daily to improve this. This is as far as we know yet, but I'm sure that in the future more topics will come. If you have questions or if you want to talk with me about it, I'm open. It's our opinion, and it could be that other people have other experience. Thank you for watching this video.